Good afternoon, everybody, and welcome to my talk on improving architecture with the Modularity Maturity Index. I'm a big fan of computer science comics, and I put one there for you. And it says, a good architect leaves a footprint. I'm going to read everything to you, so don't worry if you can't see it. A good architect leaves a footprint. And then they look at this diagram, and one of them says, we gave up finding proper names for the layers long ago. Since then, we just name them after their architects. And if you look, it's persistent business logic and so on, transport, and then there is David, Mark, Judy, and John. Voilà. And I'm always happy because there's a Judy in there, you know, a female architect. This is nice, you know, but this is a different talk. Well, you heard already who I am and where I come from. I just have 2 slides to show you what I'm doing in my daily life, and then I will dive into the topic. This is my colleagues. I'm very proud of all of them. We started 2000 with 12 people in Hamburg, and now we are 140, creating great software with great architecture, of course. And I myself, I have studied computer science. My diploma was in 1995, so quite some time ago. And since then, I've been doing a lot of programming, and around 2000, I started to be project manager, architect, and all that stuff. And I wrote a doctor thesis about complexity of software architecture. And this is sort of the founding of everything I do and everything I teach my colleagues, and I would want to try to transfer that to you as well. This is the basis for sustainable software architecture. We have seen many systems in our company. We created a business from that, and we are these days going into companies and helping them improving their architecture. And this is as well where the Modularity Maturity Index came from, which is in the other book, in the software architecture metrics book. And, well, what is the problem? There are people calling us, oh, Carola, can you come by? Yes, we have a problem with our system. Well, what is the problem? Well, it's huge. Well, what size? Well, I don't know, 5 million lines of code. Okay, this is quite big. And well, it's so hard to enhance it and to find bugs in there. It's really horrible, and people are leaving. And then we get there, and then we find something like this. You know? And this, I think you know this. Most people know these things. This is sort of a metaphor for a legacy system. What happened? Well, the people started with quite a good idea down there, you know. I mean, we have to do something for this river. And then someone came and said, oh, wonderful, do this thing as well, build something on top of it. But we should maybe, no, we don't have time, build something on top. And this goes and goes and goes and on and on. And you end up like this. And this is what I see everywhere. I'm sorry, changing job doesn't really help. You know, it's just... So when I'm talking to students and they ask me, well, where should we work? I always tell them, well, go in your interview there, ask them if they have, how high is the coverage with unit tests, you know? And if the answer is not 80%, just don't go there, you know? It's horrible. It will be horrible. But anyway, I'm talking about those, okay? And in there, you find normally things like this. So these are classes. All boxes are classes. And the dark things, the connections, those are the relationships. So these classes actually need each other. And all these little arcs there, they are real connections to both sides. So this is a real class cycle. They are all tangled together, and the colors indicate that they come from different domain modules in this system. So this is what you find in there, and this is really, really horrible, and I will try to explain to you what to do about that. and how to think about that, your system, and how to think about something new you're building, and how to think about something old you're having. So in the long run, we have looked at more than 500 systems in all kinds of languages. Of course, a lot of Java. These parts of the pie indicate the size of the system. So we have seen a lot of small systems up to 100,000 lines of code. I don't know if you're still a student. In the university, you will never do a thing like that. 100,000 lines of code is an app on a telephone these days. In universities, you normally end up with 20,000, 30,000 lines of code. So these are the small ones. This is what you often find, 500,000 lines of code. And then there are bigger ones, up to 15 million lines of code out there. I even saw one which had 40 million lines of code, you know. And this is really, really big. And from my point of view, this means this is really, really complex. And it's so hard for people to understand and to do something about it. All kinds of languages, a lot of object-oriented languages, of course. But we as well looked into PL/SQL and other things, SAP and stuff. So, and when I talk to managers about that, they always ask me, yes, I understand, but how good or how bad are we, you know? I mean, tell me one number. One number, okay. But then we did it, and this is the Modularity Maturity Index, and I will show you how we organize that, how we get to this number. So the Modularity Maturity Index goes from 0 to 10. If you're under 4, you're bad. No? I will explain later what bad means. If you're okay-ish, you are between 4 and 8, and if you're good, you're up there. And now I will show you just 18 of the systems that we have seen on this diagram. So here are all those are the systems, the good ones, the middle ones, and the bad ones. And from left to right, it's just time. You know, this was the first one we saw, this is the second one, and the third one. So this dimension has no real intention. And you see by the size of the bubbles how big they are. So this up here is a 15 million lines of code, huge Java system, one of the biggest ones in Germany, and it has a good architecture. It's well done. This one is as well Java. It's horrible, really. I mean, they were suffering. It was even worse than this building I showed you before. This one is PHP, I think. This one is C#. And that one, this was amazing. We went to Romania, to Bucharest, wonderful town. Whenever you can go there. It's really great. And they had this huge 10 million lines of code, huge C# system. And it was a great team, and they had a wonderful architecture. It's a very, very interesting system, and we gave it a very good grade. Well, so you find all languages here and in our database for all our measurements anyway. So how do I get there? I mean, how do I give them a note? What do I do? And this comes from my doctor thesis, where I worked on complexity of software architecture. And I digged into cognitive science to find out what our brain is doing when we are confronted with complex situations. And I will show you now with, I think, 5 slides or something, what this means for our discipline. This is sort of the basis to find out if a system is modular or not. You will very easily understand, because the cognitive scientists, they have looked into our brain and tried to find out what we are doing when we are confronted with complexities such as huge cities where we don't understand how to get from here to there, complex relationships with the kings and all these people, you know, this is rather complex. And our brain has developed over all those years that humans are on Earth 3 mechanisms to deal with complex structures. And these 3 mechanisms are chunking. So we are able to chunk. I will tell you what this is. We love hierarchies. I will show you that. And our brain develops schemata. And I will show you quickly what these three things mean and how this relates to computer science and how you can use that in your daily work. Chunking is a process that is going on here all the time. Chunking means that you are picking up little bits and pieces of information and you're creating bigger ones, huger chunks. And this is, Michael talked about the Miller law with a 7 plus minus 2. This is exactly the same thing. Your short-term memory only has 7 plus minus 2 spots, storage spaces, and you have to chunk. You're doing that all the time. My phrases are longer than 7 words, this is for sure, so you're chunking. But chunking only works if the things that are presented to you are connected. So you need some structure that forms some coherent thing. You're looking at me and you are seeing Carola the speaker, you know? You're not looking at my eyes, ears, or whatever. But if I would have a water pipe over here, you would look at me and think, whoa, what is this? This would be sort of strange, you know? Chunking wouldn't work, and that's the point. You need something coherent to be able to chunk. I show you a little class, of course. It starts, well, the name is strange, not good, but anyway, it starts with something to register services, to get services, and to initialize service registry. Good thing, seems coherent, has something to do with each other. But then, you can initialize an event queue, you can send events, a printer queue, and you can print documents. Wow. This has nothing to do with each other. There are at least 3 things in here, 3 different things. So this is not coherent, and it's not easy to chunk a thing like that, because chunking is abstraction, you know, getting away from the details and all that. And in our discipline, we have a wonderful concept that is in computer science the equivalent for chunking. We are talking about modularity. This is it. If we really think about modularity, we have to connect that with chunking. So if you create your systems with chunking in mind, you will get a good modularity. We start with a joke, because otherwise you will not follow me. So one of them says, it's crucial to find a good name for a class which reveals its purpose. And then they look at the screen, and then the other one says, like crap, I don't know where else to put in. And then the first one says, exactly. You know? And the title is, naming is key. That's the point. If you can't find a good name for the thing, it's not a good module, I'm sorry, on whatever level you are. You know? And this is why I love so much all these concepts. High cohesion, loose coupling. Michael talked about high cohesion a lot before. I'm not going to dig in that again. But he talked as well about responsibility. And there was Rebecca Worth-Brooke who came up with responsibility-driven design. And there was separation of concern and single responsibility principle. So you have to find things that have one responsibility, one task to do, and they belong together on whatever level you are. And then you will add your fellow colleagues to do chunking, to work their way around. Because this is the point. We have such a complex situation that we need structures that help us to save time. And I don't know how you are, but I know that my colleagues that are very intelligent, they are not able to keep in mind more than 30,000 lines of code. And I showed you how huge software systems are. So the effect, I guess you know it as well. I think Sven talked about it yesterday as well. The other day I was programming, and it was so difficult, and I found the most wonderful algorithm I could ever think about. And I thought, well, I will never forget this. This is so great. And then I went somewhere else, did something else, and came back after 2 months. And I looked at this, and I knew that I had thought that I would never forget how intelligent I was programming this and how good this was and how great, but I didn't know anymore. And this is what not only happens to me, I think, but to all of us. We forget about something we did before, and we need guidance. We need all this from our brain that we find our way around. So modularity is the first one. Second one is hierarchies. Hierarchies, well, this is very easy. Hierarchies is something that human brain loves. We love to have an abstract level and then details under it. We prefer them from networks. This is something that the cognitive science have exercises and tried out and did analysis of it with people, and they found out that people really prefer hierarchies. Just believe me, and we will come to hierarchies later, but I think you know what this means in software, don't you? We have to have some hierarchical layering in our software, and I know that the E is missing in here. We can put it in later. Okay, but the most wonderful thing of these three cognitive processes is schemata. And I will show you now what this means, because this is really great. If I tell you, my parents, they were teachers, then in your brain, the teacher schema starts to work, and you think, oh, this is why she's talking so much. Or you think, oh, must have been a dreadful childhood, how horrible, with two teachers. Yeah, you know, the content is not important. Important is what your brain is doing. You are thinking about your own teachers, if they look like me or whatever. Okay. If I tell you my father was a hammer, there's nothing. You know, your brain is like, what is a hammer? My God. A hammer? No, not a hammer. A hammer. Well, hammer, that were the people before we had trucks and trains and airplanes who transported the goods across the hams of the Alp. And they were called hammers. But it's not about hammers here, okay? It's about schemata, and about you realizing that if you don't have the schema, you don't know, you don't have any associations, you don't find your way around. This is the point. Okay? Schemas are important so that we find our way around. And the second point, what the cognitive scientists did, they took a chessboard. They took a chessboard with all those chess pieces on the chessboard, and they arranged them on the chessboard and showed the chessboard to someone who is really, really great in chess, you know, an expert. And they said, well, look at it and memorize as much as you can, and after 10 minutes, we will take the chess pieces off. Oh, 10 seconds, 10 minutes, much too long. After 10 seconds, and you just put back all the pieces you remember. And they did this with an expert and with people who don't know anything about chess. And the result was the chess experts were able to put back the double amount of pieces than the people who didn't know anything about chess. But only then if on the chessboard there was something meaningful for chess. The pieces were set up in a way that for chess meant something, that was a proper setting, you know. If they just put the chess pieces on the board somehow, you know, mixing around black and white and all that, both parties, the experts and the people not knowing anything about chess, were on the same level. Why? Well, you might already know, because the experts used their chess schemata to memorize, to know more, to memorize more of the setting. You understand? And the people not knowing anything about chess, they didn't know, so they did the same all the time, with or without a meaningful setting. Yeah? And this is the point, you know, this is the point. And we do have a thing like that in computer science. And this is such an amazing point. We do have this. We call it pattern, design pattern, architectural pattern. We have it. We have it, and we have to use them consistently. If we don't do that, we sort of take away all the capacity of schema in our brain. So the third thing we have to do is we have to use our patterns consistently. This is of major importance. I know you all know design patterns, I guess, and if you have them in your system, please, please, please write down what each of them does, because the next one who comes, this will help him so much to understand what's going on if you are using the right patterns. You know? Little example, class diagram in some module controller, model view controller, you might know model view controller, service, entity value object. This is domain-driven design speak, but you can as well write here business object or whatever you want. And I was searching for a bug with a colleague, you know. There was something wrong in the front end, and we dig through the view, moved on, model, controller, it must be down there. We came to the service, and in the service, so the first point is these design patterns helped us to be quicker, because we've got to a class, we saw what it was, we knew the pattern, and we could flow on, you know. This is what you all do. I don't know if you ever came across a class that had no pattern. It was like, ooh, what is this? I don't even know what this is, you know? In former times, it was the utility pattern, of course, where we all had this problem, you know, utility, what's this? But these days, people use utilities quite well. They know they have to be down there, you know. But anyway, so we were searching, and we came, in the service, we found a factory that was used from a service. If you have read the original book by the Gang of Four, you know that a factory is a class that creates objects. Now, you can go there, like to a factory, and ask for classes. And this was what we expected. But then we looked into this class, and there we found create business objects or entities, create value objects. Oh, but this thing was as well calculating on business objects and saving them, processing them into the database. What is going on? What is my young colleague? Oh, who did this? We have to. And I said, yes, maybe it's just the wrong name for a class, you know, the wrong pattern. Anyway, it's not about the factory class, of course, but it's about the problem that pattern, if you don't use them consistently, you lose the flow. And that's the point. So please, if you have patterns in your system, work on them, try to keep them consistent. This is really, really important. Now I will show you, well, we still have some time, this is great. I will show you some real systems and how they looked from the inside. And I will start with hierarchies and then move on to modularity and pattern consistency to really give you some ground on this point. I think when I started computer science, nobody talked about layers. Imagine this. But then around 19, people started to talk about technical layers. You have to have technical layers in your system. And this was great, you know, because at that time, we had systems where SQL statements, so database connections, were programmed in the front end, you know. This is what people did then. So technical layers, they are old now, but this is a good story, you know. It's good that you all do this, and we should say thank you to the older ones for that. Okay, these days we talk about domain modules, cutting our system from a domain perspective. Yeah? And I know you are probably all running for microservices, which is a good idea, and I can talk about that too, but today I'm going to talk about legacy. And in a legacy system, it's already a very good idea to have a layering in the domain perspective, to have some basic domain layer and other domain layers that are sitting on top, you know. This is not just a question of hierarchies, but it's also a question of modularity. Because if you think about modularity and you think about something that has a responsibility, then it should do what it's supposed to do, and other stuff should be sitting on top, and the thing on the basic thing should never have to call anything sitting on top, you know. This is not really modular, you know, modularity. So having a layering helps you with modularity as well. Anyway, I will show you a little system now, slowly, with the real view from a tool perspective. I went there at some point, and because the architect knew me, it was not so big. That system had like 150,000 lines of code. And he said, well, Carola, I know you have these tools and all this. Can you come and look with my team into their system and tell them what to do? Because I think they didn't get it quite right with the layering and all that. Because we have to do a big project, a year of enhancement. And I said, yes, okay, come. I went there a day, and we found like 60 refactorings. And then they went off to build a new thing. And I said, listen, I come back in a year. It's always a good idea to say that. I come back in a year, and then I will look at it again, you know? And then people try to really do it. And now I will show you what they did, and I was really happy when I came back. Then the system had an architecture like this. There is the technical layering. I will explain to you what you see, and later on the domain layering will appear on the right side. So what are you seeing here? In the middle, you can see the modules that we defined together with a tool, and the tool is out there, the sonograph of Hello Tomorrow. But I'm not a seller of the tool, I'm just using it. You know, this is all. Okay, so these are the modules that we created together. And on the left side, you see relationships between these modules. On the left side, they go downwards. This is why they are green. And on the right side, there are the red ones that are not good, you know, because they break the layering. And to make it clear, there's a little diagram here. So this means that this module up here needs something from down there by calling it, by using the class, whatsoever, you know. And then the layering is here. This is the user interface layer. Here comes the huge domain layer, application domain layer, bit more domain, and down there some infrastructure stuff. Okay. And this was when I came back after a year, you know, and I told them, wow, you did a good job. I mean, there is one really horrible thing, something from the business domain is using something from the user interface. And the architect said, oh, yeah. Can I have this diagram? I know that. This is the reporting component, you know, and I knew there was something wrong, but I could never find it. I can show it to my manager, and he will give me money to repair this, you know. Down there, so this is the one component. Down there, some things that we changed into yellow color because it was not such a big story. There were 3 violations, quite easy to resolve. You know. But again, a thing, if there is a violation, resolve it, you know, because otherwise someone else will copy and paste, and it will, you know, and then you have it everywhere. So I said, well, very good. Boys and girls, let's go to the domain view. And there we took the same modules and we just organized them differently. So down here, this is the basic domain layer, and then others come on top, you know. So these are all domain layers that we created with them. And when we had this, I think this is the reporting component up here. So it is again in the this is really good, you know. I really praised them. I told them you did a good job because I've seen so many horrible things, and now we come to the horrible things. Okay. The other day I was somewhere and I was looking on a 10 million lines of code system, so very big, and they started to build that thing before 2000. So actually, people were talking about technical layers, but not about domain separation or domain modules or something. Nobody talked about that. So this thing looked like this. These are the technical layers. You know, layers are like that in this tool, and modules are squares. So I closed them. And there's one thing I didn't tell you before, the coloring. The dark green is where there is everything, you know. The dark green is the part of the system that is full. And the lighter ones, so before on the other slide, you saw that there were different colorings, you know, so bigger ones, smaller ones. So the lines of code in here is huge. And this part here is about 70% of the system. And this is the business logic. And the business logic looks like this. You know. I didn't do any red and green here because nobody could explain to me which bit should be up and down. These are 90 different domain modules. And in domain-driven design, you call that a big ball of mud. You know, this is what it is, you know. I asked the tool to organize it in a way that those who didn't need any, who only needed other stuff were on top, and the one, but this is only graphically, you know. So this is really horrible, and this is 7 million lines of code, you know, like this. You know. And to work with that, and in there you find other structures. I will show you what they do, these structures. So we look at it at this hiring story, you know, to have hierarchies on the module level, but I also look at it on the class level, because on the class level, this is where you are programming, you know. You're not programming modules, you are programming classes. The other day I was at a client, I was the architect there, external architect, and they found out that I could look into systems. And we convinced the people who gave us the software that we could look inside. And the system inside looks like that. This is just part of the system. Those are the classes that were in cycles. So here is the biggest one, 119 classes in a cycle, you know, 4 different components, green, yellow, and up there is also a cycle. And I saw that and I told them, please do something about it, you know. It's just the beginning, it's not that big, do something. Find out which is on the top, on the bottom, how they should be organized hierarchically. And where is modularity? And they said, yes, 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 we will do that. And then 2 years later, I was there again, and then the thing looked like this. Huh. Yeah, this is what cycles do if you don't work on them, you know. They are like dark holes, you see? Very dark in the middle. Why is it so black there? Because there are all those references. Yeah? They are all needing each other. If you pull, you can't get anything out. If someone asks you to do another blue one, what are you doing? No, please leave me alone. I don't want to touch this thing. Well, the customer is paying. Okay. Okay. I will copy a blue one and change what I have to change, you know. And then you are in there. This is what happens, you know. And you see that one, you know, which was not connected. Now it's down here. It's this. So please, if you have cycles, work on it. Otherwise, your life will be a bit like in this comic. I cannot reproduce the bug from yesterday. And then they look, and then the other one says, well, maybe a time-space discontinuity has come by and moved us into a parallel universe where this bug has never existed. And the other one thinks about it and he says, oh, sounds reasonable, I close this ticket. You know, this is what happens. This is what happens with huge microservice architectures as well, but this is a different story. Okay, so I talked with you about hierarchies. Now I will show you a bit what tools can do about modularity. The other day someone called me and said, could you have a look at our system, blah, 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 1 million lines of code, and so on. And I said, yes, let's do it. And we did the architecture, and we had one bit that had 950,000 lines of code, and these are the satellites, you know. And I said, wow, I mean, for that, I mean, it doesn't even really help to separate these things. You know, they are just separated little bits and pieces. This is what we advise as well at the beginning. If you want to cut down a huge monolith, of course, start with little bits and pieces. But this can't be the end, you know. And then I said, well, can I have a look inside? I call this uneven modules, you know. Can I have a look inside? And inside it was like this. These are just modules as well. It's just a bit of a different form. And you see, this here is the monolith in the middle, the green one, you know. And this monolith, there are a lot of cycles in there, you know. And their tooling, Maven or whatever, didn't allow them to have cyclic dependencies between modules, and nobody gave them time to clean up. So what did they do? They put everything that was in a cycle into one big thing and the rest around, you know. So if you want to have a look at your system, use one of those very, very cheap dashboards that calculate the sizes, and if there is something big, get suspicious. Yeah? Look at it, get suspicious, because normally there is the problem in the big ones. Yeah? Probably some cyclic structure, something like that. Okay, and now patterns. We are still in time. I guess you all have patterns in your systems. And I hope you have something like model view controller service. We saw that already. So all domain modules should be constructed with patterns. When I get into a company to look at their system, we start with technical layering, then we start to talk about domain layering, and all along I listen. And if people discuss with me sort of red connections between layers, you know, violations, I listen what they are saying, and very often they say, oh, no, a service is not allowed to do that. Let's look at it, you know, or a controller can't call whatever, you know. They talk to me in patterns, you know, those people, and then I know they have patterns. And then we start to ask them about their patterns. There are some companies that have a real good pattern language already installed, and they form new people on these patterns. But often this is sort of a thing done on the side. So we start with a chessboard, with a board, and we write down all the patterns and try to form them, and then we collect the classes from those patterns into separate layers. So we create a view of the architecture from a different angle. You know, in here are all the service classes, wherever they are, in whatever package or module they are. In here are all the processes classes, importer classes. So you see the system from a pattern point of view, and this is a really good version. 90% of the source code in this system could be assigned to pattern. This is always a question, and a very low number of violations, you know. And I show you one last slide about patterns, because for me it's so important that you get your patterns right in your system. Yeah? The other day I found this cycle here in a system. What do we have here over here? A class that is called plugin manager, and this plugin manager knows many commands. You see, many commands directly, vice versa. This is you can find this very often in old systems. I call it a star cycle. Don't touch this part. This part, it's old. I mean, if you want to, you can do it, but this is normal in old systems. Just don't do anything about it. The problem is down here with the red line. So in here, there is a plugin property, a class which offers properties. So this class should only be used by other classes. But what is the property class doing? The property class is using a class that is called property helper. And by this, there is the cycle. I mean, you know, I was fighting utility classes for a long time. Today, I'm fighting helper classes. I don't know who came up with this idea to call things helper classes. I mean, you know, because in the first place, oh, there is something that is helping. How nice. Oh, this is not dangerous at all, probably. I'm going to use it. Nice. You know, I have no problem if you name your classes helper classes. But please define what they are supposed to do and with whom they are supposed to work, you know. Because I'm sure nobody who programmed this property helper intended that a plug-in property class would call it, you know. So the main point about patterns is to define what the class is doing, what is a helper class doing, and with whom it should work. This is what you can see here. There are restrictions to the relationships. A business object should never call a controller. A model should never call a view. We all know that. And this is what patterns are about, to have restrictions to what we do. And the helper problem, the helper pattern, is not well defined. This is the problem in the helper pattern, okay? So look for your helpers and define them in a good way, okay? So that you don't get the helper problem. And the last point is related to a joke. They are sitting here, best practice in application architecture today, use layers to decouple. And this one says to the other one, and every year we mount a new layer to decouple us from the crap we've done the year before. But the main point is the title. The title says annual rings. A tree has annual rings, you know. The other day I was with a client, and his architect and me, we were discussing the results of our analysis. And I told him, well, listen, you have to reduce the numbers of patterns here. There are so many different patterns. This is not a good idea. Just calm down to some basic amount of patterns that everybody has to understand. And the architect said, well, I know what you mean, but I can't do that. And I said, what? You can't do that? No, listen. Our programmers, they are artists. They have to invent new patterns every now and then, otherwise they are not happy, you know. Our software has annual rings. And I was like, okay, annual rings. I mean, you know, trees have annual rings, and it's a good idea to have strong rings on a tree, you know. Then he had enough water that year. But for software, this is not a good pattern to have strong annual rings, okay? You will have them, I'm sure. Everybody in their legacy has annual rings. This year we did it like this, next year we do it like that. But try to get it down to the minimum possible, okay? It's not a good idea. So, annual rings, this was about that. I hope I could tell you a bit how a well-formed architecture should look like, responsibility, coupling, all that, no cycles, consistent pattern language, and all this is cumulated into the Modularity Maturity Index that I showed you at the beginning. And one last slide on how we do that. What are we doing? Well, we are having a complex algorithm to do that, and you will not be able to read it, but it's all explained in the book, and I will just show you. So we have 22 different factors in these three categories. So there is modularity. These are for modularity. Those are for hierarchies. And those are for pattern consistency. And they have a different percentage on value on the result in the Modularity Maturity Index. And how do we get them? Well, we use metric tools, the blue ones here with metric tools. We do architecture analysis. And in doing that, we accumulate other metrics. And we are reviewers because we have seen other systems. So all this is accumulated to calculate the Modularity Maturity Index. And I hope that you're not going off like this now. And thank you for your attention.
Thank you so much, Carola. We have several online questions. So the first one is, what tool did you use to create the classes relations diagram?
I used an older version of the sonograph, which is out there, but the sonograph does similar things. So.
Okay, thank you.
But there are other tools. I mean, there is a whole website in Wikipedia on static analysis tools. The point is, if you use an open source tool, I don't know, there's some, you will only be able to see the actual status of your system. You will not be able to do visual changes, to do what if analysis, to try out, to change it. And if you want to do that, if you want to do real architecture work, you need a tool like that, and these tools, they cost money. It's just like that, you know. We can't do anything about it. Open source tools will never arrive at that level. So.
Thank you. Another question is, what tooling do you recommend for the modularity analysis?
Well, we use Excel. No, my colleagues have programmed some Python scripts in the Sonograph, but I mean, you know, in the end, it's if you know what it's about and you follow this table, you just know I have 10 this percentage of cycles in here. This means for this metric, this and that. So it's not so difficult.
Okay. Next question is, how could I measure MMI in a distributed architecture?
Oh, very good question. Well, you can measure it for all the single bits and pieces, which actually several clients of us do. They have, they don't program themselves, they just use products, and they ask the companies who offer them the products that we do an analysis there to have the Modularity Maturity Index to see, oh, this one is really a problem. I have to invest some money in there for refactoring. But in the end, you can do it for each of them on their own, or you can try to get all these different, if those are microservices or whatever, together into one database. This is possible. It's just a bit of work.
Okay, thank you. Do you recommend the usage of architectural decision records?
Yes, of course. Absolutely. If you do anything as an architect, don't do diagrams, but write down why you have done something. Write down your decisions. They go off the same like your understanding about some solution. I don't know if you have ever had that, but when someone comes by, why did you do it like that? I don't remember. I know it was a big discussion, you know. Write it down. Write your architecture decision down and persist them for the future. Yeah.
Okay. Did you find better index values for microservices architectures?
No, I use the same, but because they're the same question. Do I have high cohesion, loose coupling? You know, this idea of sending around events that this might be loose coupling is sort of is not really the case. If there are so many events running around, you get lost again. You know, loose coupling means not much coupling. Less is possible.
Okay, perfect. Any other questions?
You can reach me on Twitter or per email, because I have to run off to get my flight back to Hamburg. If I don't answer on the first time, just send a second email. This happens, you know, I'm sorry, but the second one, oh, yes, I remember, I had him. Yes, oh, yeah. So don't worry, it's just because there are so many emails all the time, okay? Just try it again.
Okay, thank you so much, Carola.